potential dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive.
Hi everyone, my name is Harsh and this is my submission for Gemini Summer of Code. So first we'll walk through the repositories that are a part of submission and then we'll look at the technical details in brief. So here you are looking at Sudomentor, which is my main toolkit. It has agents, a knowledge. Knowledge would be something unique that I have done for this project. And we have an app skeleton. This is a very basic controller app which can perform basic actions related to KML with Liquid Galaxy system. And then we have the license which I took from the internet, the MIT license, and there is a README file. So the README contains all the details right from explanation in technical terms of how everything works and what is the folder structure, along with how you can run your system, how you can run it on your system. So I'll be showing and explaining you everything that is mentioned here in depth. Second part is the sample LG app. This app was made in under 20 minutes entirely by the Copilot or the Gemini that comes with the Antigravity IDE. So let's first look at the main toolkit. It's this one. So let's start from the beginning. It has a folder for agents, this one, sorry, and agent has skills and workflows. Anchor.md was made in a later phase when I was testing out the toolkit. Sometimes it occurred that the assistant did not refer to the agents and the workflows that I had added. So to fix this, I have added anchor.md. It kind of forces the agent or the AI to look at all the things that I have mentioned. So there are a few, not few, but a lot of agents and workflows. So I'll explain all of them. But before that, I'd like to tell you in brief about the knowledge that I have created because a lot of agents refer that knowledge that I have created. So this knowledge is kind of the entire knowledge of the LG wiki that I have made. So first, I scraped the LG wiki. The issue here was that there are not independent routes. Sorry for the noise. Sorry, there was a dog barking. So the issue that I faced during the scraping of LG wiki was that there were no separate routes for every entry of the wiki. So I noticed that there was just one single route where you got an HTML, very large amount of HTML content, and it was all rendered on the client side whenever I press that particular entry. So what happens is that first I scrape the entire wiki and it gives me an HTML content that has a lot of things like almost the entire wiki. So it is scraped and then we get something called as LGWiki parsed. So the entire HTML that we have, it is divided into sections. So you can see the titles. This is all just a Python script which has made this. So it divides the entire HTML into sections for a markdown in markdown format. So you technically have all the knowledge that you can refer to, and since it's always verified, you can trust this knowledge. So scrape wiki gets you the HTML, and then split full page will parse all this HTML content into these markdown files in the wiki parsed directory. And what I have done of all this knowledge is that I have converted into vector embeddings. Now, Embeddings are a numerical representation of all the knowledge that I have gained from the LGWiki. So let's say I have a paragraph about how SSH works and how we need to configure some networking settings in virtual machines. So there is an entire paragraph for this. And if I ask any kind of question to a chatbot, it does not directly read plain English. So everything is converted into numbers because LLMs and any other form of AIs, they just convert text or voice input or visual input into numerical formats, and they perform operations that they were trained to do. And they again output some numerical things which are converted into again a voice or a visual output or a response, a chatbot response, anything like that. So I have used embeddings Gamma. It is a lightweight model, I think around 6 to 800 MB in size. It will uh, convert all this knowledge into numerical representation, and it's then further like it looks like just a huge array of numbers. So you can see this is for the home.md of LGWiki, and it has converted all the meaning that was stored in home into numerical format. So the part where this is used is the buddy chatbot. Now what a contributor can do is, if they are new to this Liquid Galaxy system. So I have activated it here. Right now it's working on my terminal. I was planning to create a UI as a separate project for this chatbot. So for this context of the toolkit, you can ask any kind of question to it. Let's ask it, hey, can you please help me understand the logic of adding or sending KMLs to Liquid Galaxy. And now it's a bit slow. I wish I can make it faster. Meanwhile, I'll explain what is happening here. My question was again converted into some numerical forms, and it is now being compared. The numbers of my question are being compared to the numbers in the knowledge base, and wherever the model embedding schema would find something similar, there are multiple ways of finding this similarity. A popular way is cosine similarity, in which we find how close it is by calculating the cos function of that particular set of numbers. So once we have that similarity, we can also, if you'd like, you can try query embeddings.py. It will use the embedding gamma model to get you the top X number of queries that you have in the code, and it will give you the similarity score. So it's a fun way to try that out. Right now, it's finding out if it has some relevant context in the wiki stored, and then I have another gamma model which will produce a natural language output based on the knowledge and give you the output. By the time this works, okay, it's working. So this is the work, this is the result of the work of embedding gamma as well as the gamma 2 billion model. I think it's in the range of 1 to 2 GB. So it's creating the output in natural language. So a contributor can ask any kind of question that they wish to know about, and it will explain you everything. Here I have given it a few prompts which will explain it the logic, but always it won't give you the exact code that you have asked for. It will force you to learn and read a bit, and oftentimes it will share you the link of LGBTQ itself. So it will promote you to read more and learn a bit rather than just directly copy pasting. And this is the knowledge part. So you can see that it has shared a lot of things, like it has first recommended LGWiki, and here it has described a lot of things about the KML and how we can use it with Liquid Galaxy. After that, so this was the entire knowledge part. Now let's see the agents. So their skills and their workflows. Now here also the process that happened was that I initially had a few skills, but then when I was testing this toolkit, I felt that it's not always, the agent is not always referring to the correct agents. So slowly I added more and more agents as per requirement. So LG Auditor was something that was built in the later stages. It is a specialized agent for auditing and implementation of plans. Now this was made because it was not always following the instructions that I had mentioned in a few more other agents. So it it forces the agent to adhere to a particular set of rules that I had defined. These were a few issues that it was not following or not really understanding maybe. So I added these rules again to highlight that you need to do this. And after that, we have first I'll explain the main agent. So the function of main agent is like to sit in between, uh, like what MCP does. Like it's not MCP, but you just call the MCP server, and MCP server will take care of all the external plugins that you have. So generally, the agent will refer to the LG main agent, and main agent has knowledge about all the other agents that exist and some other workflows that exist. So it will, divert the tasks to many other agents. So after that, we have code reviewer. It is a specialized reviewing agent for reviewing code, architectural consistency, and wiki standards. So it will just adhere to a proper coding format. After that, we have LG Planner. Its function is to create well-structured plans for accomplishing any kind of task that you provide. After that, we have LG Quiz. This was referred from Mentor Victor's web-based toolkit. So it will ask you some questions. Sorry for the noise. So the coming back, the quiz agent will test the knowledge of the contributor. It will ask you questions for the tasks that you have done. LG Scholar is an interesting skill, my personal favorite skill. Its function is to refer all the markdown files that I have created in my knowledge and inside LG Wiki past section. So it will, always refer to the right knowledge and apply the right kind of way or a particular correct workflow to accomplish the tasks. And we have then security. This will ensure, not always ensure, but it will always try to make sure that the code you have written is secure, or you might have made sometimes some mistakes that were missed, but they could have been bad in terms of security of the application. So it will try to go through your code base and check if any mistakes are made or not from a point of view of security. Now there are a few workflows that I felt I had to add. So right now, for balloon, it's just a basic image that I have added in the sample app itself also that I will show, and it can be modified into a specific index according to the use case of the application. Then we have bootstrap session. So this is one of the first workflows that will come into the picture. It will give you a general overview of what things are, because this was also made because initially it was not referring to the correct workflows and correct agents. So these things were created to ensure that it always sticks to some kind of right path. Then we have a Flutter controller workflow. This workflow contains all the important instructions for creating a basic controller for Liquid Galaxy application. And again, here it also the mistakes that were made by the toolkit while making a sample app, it missed a few points, so I added those instructions specifically in this workflow. Like it sometimes made mistakes in SSH configuration, so I gave it a standard or a rough template, you can say, to implement SSH connection. Then we have create KML, so it has knowledge about creating or instructions of creating 2D and 3D KMLs. Also, we have debugging LG connections. So again, this was also created uh, to ensure the application works properly. So the common errors that were faced in LG Wiki Discord chat, as well as from my experience, I have added them here in a well formatted way as a workflow. So if there are some issues while the agent is building the app, it can refer to this particular workflow to debug it. Then we have manage remote assets. These things are also made for the purpose of debugging, because often the agent got these things wrong. Uh, so after that, we have again this particular workflow was created by Gemini itself. When I said to it that while making this app, what did you feel you could have known in advance so that you would have made less mistakes and built the app faster. So this workflow was made by Gemini in order to note important points that it could refer in the future for other contributors. Then we have work with Maps API. This particular workflow is a bit of common knowledge for implementing maps with the Liquid Galaxy application. And then we have anchor.md, because the toolkit was not always adhering to the correct workflows. So it has again a few instructions to adhere to a particular knowledge or particular agents and workflows. I have tried a lot to make the agent stick to what I have. Then this is just a rough controller application. I'll show you a full new application that I have made using this toolkit. Let's look at that. That's this one. So I'd like to show you as a proof that everything was built by Gemini itself. I have cloned this particular uh, toolkit that I just explained, and everything was made completely by Gemini. So it took it sometime less than 20 minutes because there were errors. Then again, it referred debugging steps, and finally, it built the application. So I'll show you the app now. Let's bring forward the Liquid Galaxy system. LG3, LG2, LG1. Where is LG1? Here it is. So this is my Liquid Galaxy setup. Now I have also run the app. Where is my app? It's here. Okay. So even I was, shocked to see the app that it built because specifically I did not have any kind of these things in this sample controller app that I have. Here, the app skeleton that you can see on the screen right now, it is very basic controller, similar to that controller that we have built in Task 2. So here, in place of that skeleton app, it has created my app, and let's just try it out. So I think we'll fly to Tokyo. It sends it the fly to view to the city of Tokyo. Okay, is this Tokyo? I don't know. Okay, looks like that since it's Japanese. This is the setting space that it has made. I have connected it to my Liquid Galaxy rig, and let's try entering something. I want to go to my college, VIT Pune. I don't know if it will find it. Let's see. Oh, okay. So it found my college, Vishwakarma Institute of Technology. There are a lot of slums surrounding my college, but my college, uh, it's a bit small, but it's nice. I'll say that. Then let's try sending a logo. It is a Flutter logo. I can also add the image for Liquid Galaxy in the assets folder. So instead of Flutter, a Liquid Galaxy logo would be better. Then again for a sample balloon, I had a basic image which can be replaced to a specific kind of index for better visualization as and when required. Then let's try clearing this. So the image and the balloon, so alleged balloon has disappeared. You can also shut down, reboot, and relaunch it. Then let's try something. It executed LG reboot now. It will take a lot of time to reboot everything. Okay, so that was my application, and this is the folder structure of the app which the toolkit has built. This is all the things that it has done. This was my basic prompt, and after this, everything was done by it. We have lib, here we have screens, home screen and setting screen. Then we have services, the most important part of the application. We have also utils. So again, this folder structure was provided by me in the workflows, since my previous apps also had a similar folder structure. So all these things can be modified according to requirements. That was my application. And where's GitHub? I also have a few diagrams that I'd like to show. It's in my README, not this, not this. Uh, chat. Yes, I have created a separate independent repository as a project for the chatbot itself, and it has a few explanatory images. So, if I ask a question, it is converted into numerical representations. Then the database or the script embeddings that I had made for LGWiki are sent to an LLM. So this part of the pipeline is done by embedding schema. Also, the creation part of the vector database it's sent to an LLM, which is Gemma 3, 2 billion, I think 2 billion. And the wiki snippets as well as the natural language answers for that question that you asked are given as output to you. So this is rough. Okay, it's Gamma 2B. So that was my submission, and I'll be adding links to all the repositories as well as the application and everything uh, as it was mentioned in the Gemini Summer of Code Google document. So thank you so much for watching this video.
So hello everyone, my name is Vinayak and this is my submission for Gemini Summer of Code contest for Liquid Galaxy project. So in this project I created a Flutter Liquid Galaxy starter kit which is very similar to Liquid web starter kit created by the mentor Victor. So this starter kit includes a Liquid Galaxy connection setup and command execution and KML generation which allows user to easily control the Liquid Galaxy rig. So here I have demonstrated this by building a Liquid Galaxy controller. So in my tasks one, I took a lot of time to build this controller, but we'll see like how this anti-gravity can build Liquid Galaxy starter in just a few minutes using the Liquid Galaxy Flutter starter kit. Now it'll go under multiple process. Like we have created an agent folder in our rig. From there, the anti-gravity read all the necessary actions to be taken, and then it'll start generating the code. So we have had few questions also like to which it should ask from the user, but as of now it is not asking, so we have to check on to it now. So along with this, I have implemented this agent workflow that allows a user to provide only an idea, as I did, and the AI automatically generates the Liquid Galaxy application using this starter kit. So we can see it has created some Flutter application, which is running here. So as of now, I have just opened one visual. So as of now, I have just opened the master node, so we can get a better visualization idea. So we can see this is our mobile screen, which is created by our agent. So as we'll click, these are the auto-filled credentials that I have given. So as I'll click connect, it'll connect to the system, to the Liquid Galaxy rig, and we can see this. And we can perform all these rest of the actions here. So we'll perform one by one. So thank you for reviewing my submission.
Hello everyone, I'm Soumya Bhattacharya and I will be talking about the Liquid Galaxy Flutter Starter Kit. That is a code base specifically designed to standardize the foundation for future Liquid Galaxy projects. The application that I've built with this kit uses clean architecture principles, which serves as a strict rule about how the data flows through the application. So for this application that I have built using the LG Starter Kit for Flutter, first we see that the application is disconnected and move on to the settings page where I have given all the required credentials here and we click on connect to Liquid Galaxy and yeah, it has connected to Liquid Galaxy. Next, we have all these buttons. Let's first fly to Paris. So you can see that on the left hand screen, I have the logo and on the right hand screen, I have the details about Paris and we have flown to Paris here. If I click on show balloon, there's a balloon also shown here, which is Liquid Galaxy GSoC 2026. Next, we move on to New York, where we see that we have gone to the coordinates of New York. And next, if we clear the visualization, you can see that the visualization has cleared with a pop-up show. Also, reboot the LG. To assist developers in navigating this complex system, an agentic AI system is embedded directly into this repository. We recognize that the biggest barrier to a project is not just writing code but understanding the domain itself. To solve this, we created a specialized virtual team of 6 AI agents located in the .agent/skills directory. These are not just static documentation files, they are active system prompts designed to guide the developer through a specific life cycle, creating a slow and deliberate buildup of complexity. The journey for building this application begins with the init agent, which acts as a project DevOps engineer. Before a single line of feature code is written, the agent forces the developer to validate their environment. It specifically validates that the IP address matches a standard regex format and ensures that the screen count is between 1 and 10. Once validated, it automatically generates a .env configuration file with the LG host, LG username, and LG password, ensuring these critical variables are never hard-coded in the source files. Once the foundation is secure, the workflow transitions to the brainstorm agent, who serves as the creative director here. This agent looks at the available APIs and data sources and suggests some wow factors. It understands the specific capabilities of KML, such as orbits and flytours, and pushes the developer to think beyond simple placemarks, ensuring that a final application utilizes the full visual potential of the Liquid Galaxy hardware. With this, the plan agent takes over as a project manager. It ignores the code and focuses on the structure. It mandates the creation of the plan.md file that follows a strict 4 phase implementation strategy, which is the domain, data, presentation, and integration. It also requires a risk assessment section, forcing the developer to identify potential blockers like unknown API rate limits or complex KML animation logic before they become problems in the future. It creates a mermaid chart to visualize the timeline, turning abstract ideas into a concrete schedule. Following which is the execute agent. This agent plays the role of a senior architect. When the developer asks it to implement a feature, it strictly enforces the solid principles. It explicitly reduces to generate code, which has a single file that handles UI logic and data. Instead, it forces a specific order of operation. First, defining the entity. Second, the repository interface. Third, the use case. And lastly, the river pod provider. It also validates error handling to ensure that no exceptions are silently swallowed. Finally, this cycle closes with the review agent and the quiz agent. The review agent acts as a quality assurance, scanning the code base for specific pitfalls like malformatted headers or main thread network calls. The quiz agent then acts as a teacher, testing the developer's understanding of the concepts they just implemented. This ensures that the developer has a clear understanding of the project that they have created. And this is how this virtual team helps a developer to create an application in a way that makes it easier for the developer to spend more time in their creativity and implementation strategies rather than focusing on boilerplate code and codes that could be easily fixed and are available in the internet. Architecture is composed of 3 distinct layers. First, being the domain layer, which serves as the center of the application and contains only pure Dart code that has no knowledge of screens and SSH. This layer defines the core concepts through entities such as LG connection class, which defines what a connection is, and use cases like connect to LG, which encapsulates atomic business actions. By isolating these concepts, the business rules remain constant, even if the user interface or backend implementation changes. Surrounding the domain layer is the data layer, which acts as a boundary of translator for the application. This layer takes the pure concepts from the domain and handles the communication with the outside world through repositories like LG repository implementation, which implement the abstract interfaces defined in the domain. The actual implementation details live in the data sources, such as the LG Remote Data Source class, which is responsible for importing the SSH client and directly managing the socket connection. The outermost shell is the presentation layer, which consists of the Flutter widgets and screens. The state management is handled here using Riverpod, specifically through providers like LG Service Provider, defined in the lgproviders.dat file. The user interface never communicates directly with the data layer. Instead, it watches these providers. This structure enables a reactive UI where change in the connection status deep within the data layer automatically bubble up to update the screens. Connecting to the Liquid Galaxy rig presents as a unique challenge due to the network latency, as opening a new connection for every command would make the application unusable. To solve this, the LG service class function acts as a persistent singleton that maintains an active SSH client instance from the Dart SSH2 package. Once the connect method initiates a secure handshake and authenticates, the connection is kept open in the device's memory. This strategy reduces command latency from hundreds of milliseconds to near instantaneous levels, allowing for real-time interaction with the Liquid Galaxy display. The kit also includes an intelligent multi-screen calculation feature within the LG service class using getters like leftmost screen and rightmost screen. These getters use dynamic mathematical formulas to determine the correct IP address offsets based on the user screen count configuration, ensuring content is correctly placed on any rig setup without hard-coded values. Visualizing content on the Liquid Galaxy requires generating valid KMLs. To prevent errors associated with manual string concatenation, the kit implements a KML builder class that uses the builder pattern. This class manages a private string buffer and exposes methods like addLookAt, which automatically handles complex tasks such as the altitude mode. It also simplifies the placement of 2D images on the 3D globe through the create screen overlay method, which translates simple coordinate parameters into the complex functional coordinate system required by the Google Earth.
The application that I have built with the LG Flutter Starter Kit, a structural template based on clean architecture and Riverpod, which acts as a starting point for the application LG 360 Explorer that I have built, which is a functional intelligent application capable of dynamic AI guided city tours, real time global weather visualization, and secure user friendly configuration. To achieve this, we utilize the agentic AI skills ecosystem provided with the kit. As you can see that I have already connected the application with the LG rig. You can see that first we click on fly to New York, where we can see that the application has gone to New York. It is also showing the Liquid Galaxy logo on the left hand screen, and there is a balloon that shows the details of New York, and also a KML balloon that says Liquid Galaxy GSoC 2026. Next, if we click on clear visualization, the visualizations are all clean. Then if we move on to city heat maps and then we click on New York, we can see a dynamic KML is produced with all the heat maps and the details with the temperature, humidity, wind speed, and the air quality, which is good here. Next, we can go on to London and see the same visualization in a similar manner with all the KMLs with different colors showing the heat map in a gradient format and the details that were shown earlier. We also have a Gemini guide here where I have written show me 5 places in Spain, and it shows me all the 5 places. These are all a proper city tours that we're having for each of the place in which we are orbiting around the places and flying from one place to another. We also have a tour progress here, which shows the number of places covered and the current place we are in. Following this, there'll be another 2 more places that this application will be showing that will be done. That's it for the demo. I will now walk you through our development lifecycle. The process begins with the init agent. The configuration of the Liquid Galaxy environment is often too complex, requiring management of SSH keys, IP addresses, and rig connectivity. The init agent automated this setup, validating our environment before the development began. Once connected, we engaged the brainstorm agent. We queried how can we implement generative AI with a multi-screen rig. The agent proposed the hybrid travel guide concept in which we use Gemini for narrative generation, use Wikipedia for factual image grounding, and use the rig panoramic display for the tour visualization. This was a targeted suggestion tailored to the specific hardware constraints of the Liquid Galaxy system. With this clear goal, we moved on to the plan agent. We didn't just ask start working at main.dart, we asked the plan agent to structure our world weather map feature. It generated a strict implementation plan adhering to the starter kit's clean architecture, which involved the domain layer, which defined the weather entity and the repository interfaces, the data layer, which detailed on how to query the Open Meteo API and map the JSON to our entities, and the presentation layer, which outlined the heat map view model using Liverpod for state management. This plan acted as a blueprint, ensuring that every piece of code we wrote would be testable and modular from the day one itself. We then moved on to the execute agent to write the actual code. The core engine of the application is the LG service class that manages the Dart SSH2 client for communicating with the rig. A critical challenge in Liquid Galaxy is the multi screen topology. We don't just send images, we route them. Inside the LG service, we implement dynamic screen calculation. This simple but critical logic ensures that our logo overlay always lands on the far left screen, while our information balloon lands on the far right, which is the rightmost screen, keeping the center screen clean for the satellite view. The execute agent helped us build the Gemini service. It didn't just paste standard API code, it implemented structured prompt engineering. We injected a system prompt, act as a travel guide API, return only JSON. The agent also wrote the error handling logic to strip markdown and validate the JSON response, ensuring our app wouldn't crash if the API successfully chatted instead of returning code. For the world weather map, the execute agent wrote the KML builder logic. It generates polygon KML elements on the fly to create the heat map effect. We manipulate the alpha channel of the KML color tag. We generate 5 concentric circles for each city, each with an alpha equals to 33, approximately 20% opacity. When these polygons stack in the Google Earth, they create a natural glowing gradient intensity that represents the heat levels for that particular city. To create the city tour experience, we created our city tour view model, which orchestrates this using a specialized KML structure called the GX tour. In KML Builder create city tour, we generate a playlist that mathematically calculates a perfect orbit involving first the initialization, in which we calculate the starting point at a specific range and tilt. Next is a loop in which we generate 18 sequential fly to command blocks, followed by the calculation part, which involves the loop in which we increment the heading by 20 degrees in each step. Next is the smoothing, in which we set the fly to smooth mode, giving a result where the Google Earth interpolates these points and creates a seamless circular orbit around the city, giving the user a drone like viewing experience. This entire complex XML structure is generated dynamically in Dart and pushed to the rigs in milliseconds. As we neared completion, we used the review agent to audit our work. It flagged all the critical issues that were existing in our application. The review agent caught any security risks as well that were present. Following it, we implemented the unified settings screen, in which we added shared preferences for secure local storage. We built a dedicated UI to manage both the rig connection and the AI configuration, which are the API keys. And we removed the legacy connection screen, consolidating everything into a single professional setting panel. The result that this team of agents produced is the LG 360 Explorer, which is built in days and not weeks, containing these key technical features. The first being state management, which involves a fully reactive UI using Riverpod, where the state flows down and events flow up. Next is the hardware abstraction. The LG service handles all the SSH communication, decoupling our UI from the physical hardware. Third is the smart tours, a cinematic sequence in which we fly, zoom, and orbit that automates the user experience along with the KMLs that shows the heat maps for a very immersive experience. And lastly is resilience. API calls to Gemini and OpenMeteor are sandboxed. If they fail, the app degrades gracefully without crashing. Through this project, it is very visibly seen that by combining a robust architectural template with specialized agentic AI skills, we can eliminate the boilerplate and complexity of Liquid Galaxy development. We can spend our time building features and not debugging SSH connections and other code which can easily be debugged and solved with the help of AI. Thank you so much for your time.
To a world you can see through panoramic screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid Galaxy, we see it all. Technological marvels stand